Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. Today I would like to explain about the second chapter of grade 10. Before going to say about the chapter, I would like to explain about our textbook. It is composing of 290 pages, 12 chapters, out of that 6 are physics, 6 are from chemistry. First, third, fourth, fifth, ninth and 10th are physics. Second, 6th, 7th, 8th, 11th, 12th are chemistry. In final examination, you have to answer 33 questions out of 38. The question paper is given to test different academic standards as AS1, AS2, AS3, AS4, AS5, AS6. So, most of the children may know the answer, but they are unable to write because they are less in applicative mind of concept. So, children, I would like to say one thing here. You should learn the content and apply the concept. Remember, learn the content, apply the concept. So, for that, you should get command of the textbook. When it will comes? When you go nook and corner of the textbook, line to line, page to page, concept to concept. And when you learn the concept, at the time itself, you have to analyze how the question may come from different aspects. The same concept may be asked as the conceptual understanding, the same can be as the informative skill, the same thing as the hypotheticals. So, we will see how the questions and all the things will come. I hope all of you are enjoying the coronavirus holidays. Don't think otherwise. These vacations are for you to inculcate good habits and helping your parents. So while you are helping your parents, it will make a powerful emotional bond such as first year group, 7th year group in the periodic table. Yes or no? Yes. Now, when you are free, means you are not doing any work, certainly hunger is more. Certainly hunger is more. So, I think most of you are searching the refrigerator each hour or 1.5 hours like that, because to eat something. For that, I too brought something for you. See, what's this? First, a lemon. About orange. And about the mango. And a 3 idiots for you about the tamarind. So, and this mango is searching for your right answer. What is the taste of it? What is the taste of this tamarind and the lemon and this orange? Yes, absolutely correct. That's sour to taste. Why these are sour to taste? The common criteria is sour to taste. Why all these are having sour to taste? Yes, correct, acids. So, our present topic is about acids and bases, and of course salts. So, when you observe here, acids, bases and salts. Look at this color: acids red, bases blue, salts white, and underline this bases with yellow, and of course let us consider as the pink. Right. So what are these acids? Already you said that acids are sour to taste. Besides this, some physical characters are there for the acids and bases. Physical properties. Let us see the physical properties of the acids and bases, and later we will see how we can prepare these acids and bases also. Acids are the substances which are sour to taste and which converts the blue litmus into red litmus. Here what is named for as litmus. Litmus. These litmus solutions are obtained from one plant, that's about lichen plant. This lichen plant belongs to Thallophyta family. Thallophyta family. So this Thallophyta family lichen plant is useful to create litmus solutions. Once the question is given like this, the litmus solutions can be attained by the family of dash. Okay, so options was given. Out of that you have to be selected. So litmus solutions can be attained from the plant of lichen, which can be attained from the Thallophyta. Right. So from this litmus we are having blue litmus and red litmus. And blue litmus will convert into red by the acids. Converts into red by the acids. So acids, mostly I wrote in the acids with red color. Because what is the color of red? Dangerous. Acids are also dangerous. So mostly the indicators colors are red in acidic solutions. And the basic solutions, mostly these bases are bitter to taste and convert red litmus into blue. So I wrote the blue and underlined with yellow and pink. Remember that. And salts. Most of the salts are white in color. Now we will see how can we attain these acids? How can we prepare these acids? Very easy process. See children, what is this? It is a soda. It is a soda. So when I am going to open this soda, you may observe some gases are coming out. So some gases are coming out. So what is the gas present in it? What is the gas present in it? Yes, carbon dioxide gas is present in water. This gas is present in water. That what we call soda. Let us see how they prepare and how these acids are prepared. Very easy process. The preparation of acids. So when the non-metallic oxides dissolves in water, when they dissolve in water, they produce acids. So it is about the general equation. Children, you have to remember one thing. You should be analyze the general equation. Then it is very easy to understand whatever the equation that what you want to build. So non-metallic oxides. Now here non-metals we need, their oxides we need, water we need. Let us see some non-metals. Carbon is a non-metal, sulfur is a non-metal, phosphorus is a non-metal, and of course etc. What we need? Non-metals? No, non-metallic oxides we need. So carbon is having two oxides, carbon monoxide, carbon dioxide. Similarly, sulfur is also having sulfur dioxide, sulfur trioxide. Of course, phosphorus, nitrogen are also having the oxides. So what is our primary? Non-metallic oxides. Carbon is a non-metal, sulfur is a non-metal. Their oxides, carbon dioxide, sulfur dioxide, sulfur trioxide. These are the non-metallic oxides. Now non-metallic oxides are there. Look at the general equation. When these non-metallic oxides are dissolved in water, they are ready to produce the acids. Now already we saw that carbon dioxide. This carbon dioxide dissolves in water. It dissolves in water. Then what happened? See the general equation. Non-metallic oxide dissolves in water. It's ready to produce acid. Let us see that acid. H2CO3. Okay, H2CO3. This is called as carbonic acid. Carbonic acid. So this soda is nothing but carbonic acid. Why this is soda? Because what is there in it? Carbon dioxide, which dissolves in water. Carbon dioxide is a non-metal oxide, non-metallic oxide dissolves in water, it's ready to produce carbonic. There are several methods are there to produce acids. It is very easy process to produce acids. Non-metallic oxide dissolves in water and produces carbonic acid. So it is the chemical name carbonic acid. If you see here, carbon dioxide dissolves in water, soda. So there is a common name for this. The common name of this one is about drinking soda. Drinking soda. Okay. So here one more bit will be asked like this. What is the anhydride of carbonic acid? Listen children. Anhydride. What is the opposite word of happy? Unhappy. Hydrate means water. Anhydrate means, that's correct, without water. See this carbonic acid. What is the question? Unhydrate. Unhydrate. Hydrate means water. Unhydrate means without water. Simply remove the water from here. H2O. Remove H2O from this. One H2 and one O is removed. So after removing this H2O, what you will get? Is, that's correct, CO2 will. So the anhydride of carbonic acid. Anhydride of carbonic acid is about carbon dioxide. So the bit may be asked like this. We are having in the syllabus maybe carbonic acid like that. But the content how they are asking based on your concept. So analyze the concept properly. Anhydride. Anhydride of carbonic acid is about CO2. Now let us see one more. Sulfur dioxide dissolves in water, we use sulfurous acid. Sulfurous acid. And we are going to sulfur, of course we will see this one. Okay. So sulfur trioxide dissolves in water. What happened? It will use, yes, see that one? H2SO4. H2SO4. It is called as sulfuric acid. Sulfuric acid. It is the chemical name. There is a common name for this about king of acids. King of acids. So you should remember the common names as well as the chemical names also. Now let us see once again how we can prepare the acids. When non-metallic oxides dissolves in water, they are ready to produce acids. Now non-metals, carbon, sulfur, phosphorus, nitrogen, of course extremely right of the periodic table, some 50, those are going to be considered. That topmost elements are going to be considered the non-metals. These non-metal oxides, those are non-metallic oxides. When they are dissolved in water, they are ready to produce acids. So when non-metallic oxide dissolves in water, they produce acids. Okay. So like this, nitric acid, phosphoric acid, all those things can be added. See once again how we have to identify. What we need? Non-metallic oxides. When they dissolve in water, they are ready to produce acids. Carbon dioxide is a non-metallic oxide, dissolves in water, produce carbonic acid. That common name is drinking soda. Anhydride of this one is carbon dioxide. Anhydride means removing of water. Now tell me what is the anhydride of sulfuric acid? Is remove H2O. What you will get there? Is SO3. So the SO3 is going to be considered as anhydride. Anhydride of whom? Sulfuric acid. Okay children, have understood? Okay, now let us see how these solutions, means acids and bases, how we can identify these solutions. To identify the solutions, we are having so many indicators. Okay, so in that, litmus paper, blue litmus, red litmus, and besides this, some more indicators are there as methyl orange, phenolphthalein, universal indicator, and olfactory indicators. So like that, so many indicators are available. Okay, litmus, blue litmus, red litmus. and methyl RH, phenolphthalein. Besides this, pH universal indicator and some olfactory indicators are available in the market. Okay. Now, how these are going to change us? How these solutions will change their colors? Okay. We will see how the acids and bases will change their colors in different indicators. Okay. Children, see this chart. It is about the content, and you should learn this content. Later we will see how the questions will come up. These are the indicators, and it's about the acidic medium, it's about the basic medium. So already I told you that different indicators are available. Among that, red litmus. So what is the color of red litmus in acidic medium? It remains same. It remains same. In the basic, this red litmus turns into blue, and this blue litmus in acidic medium turns into red, whereas in basic it remains same. And methyl orange in acidic medium red, methyl orange in basic medium yellow. Phenolphthalein in acidic medium it remains colorless. It changes into colorless, and in bases the color of phenolphthalein is pink. So whenever you are listening, first you have to maintain one running notes, and I am giving some time to tabulate this. It is about the content. So from this content, how the questions will come? Once remember, red litmus changes into blue by bases but remains same by the acids. Blue litmus turns into red in acidic medium and it remains same in bases. Methyl orange changes into red in bases yellow. Methyl orange acids colorless, bases pink. It is about content. Now based on this content, how the conceptual question will come? Let us see about it. Yes. So the question is given like this. There are three different solutions. Three different solutions in three identical test tubes. So these are the test tubes. In these three test tubes, let us consider as A, B and C are the test tubes of different solutions. In one test tube we are having one solution. In another test tube we are having another solution. So these are the different solutions. In this we are having one more solution. So these are the different solutions. So the question may be asked like this: the three different solutions in three different test tubes, and only one litmus paper is given. Only blue litmus paper is given. With the help of this blue litmus paper, we have to identify the nature of the solutions of A, B, C. Okay, so already you learned the content. What is the color of the different indicators in different solutions? Now there are solutions and only one litmus paper is there. With the help of this, you have to identify the nature of the solutions. Okay, for example, first I am going to take this blue litmus paper and I inserted the blue litmus paper into solution A. It remains as usual. So there may be some chances of this A may be the base or may be neutral. Don't forget, litmus solution may be in the purple color, the neutral solutions. Okay, not the paper. Right. Now again I inserted this blue litmus paper into this one. Means the B solution. There it changes into red. Okay, so it is clear that the blue litmus changes into red. So what is the nature of B solution? Yes, it's about acidic in nature. Now take this one take this one which converts into red and insert into this. Here again it unchanges. For example, it remains unchanged. Red color is as usual. So the red litmus or maybe the blue litmus does not affected by this one. So it is neutral. It is about neutral. Now take this one. Now take this one and insert into this. Here already some portion is red now. Now when you insert into this A solution, it changes into blue. This red changes into blue. Which converts the blue litmus into red litmus? Yes, you are correct. It's about base. So it's clear that it's a base or it's acid or it's about neutral. So what we learn, the content can be applied in different nature. Let us see a small activity based on that. And one more thing, whenever you want to write, just pause the video and note it down as a table or maybe any activity. Okay, just pause and note down. Noting the running notes is very important. Yes, let us start the activity. Just to identify the nature of the solution, whether it is acidic or basic. For that purpose, here we are having the apparatus, test tubes, 3 test tubes, and 3 different solutions. We don't know the nature also. Now we have to find the nature. So first I am going to take one solution in one test tube. Yes, it is one solution. I am going to take some solution in test tube. Let us consider as A. Okay, it is a solution. Now, in another test tube, let us consider a test tube B. In this, I am going to take the some amount of solution. In third test tube. In this third test tube, I am going to take some more and the solution. Like this. Now we are having 3 solutions with us. 3 solutions in 3 test tubes. 3 test tubes, 3 different solutions. Now, first I want to test the nature of this one, and this one. So for that purpose, I am going to add some phenolphthalein solution. Some phenolphthalein solution to all these 3. Let us see. Okay, children, are you following? Yes. Now it's about the indicator phenolphthalein. What is indicator? Indicator is a substance which is used to identify the nature of the given solution. Now I want to know the nature of this solution by this indicator. Okay. Now among these, first I am going to take this one. Okay. Right. I am going to add some phenolphthalein to this one. Let us see what happened. Nothing is happened. Means remains same. Phenolphthalein remains unchanged. Means colorless. Remains colorless. What is the nature? Maybe acid. Let us see. And I am going to add this phenolphthalein to this second one. See what happened. It changes into pink. So, which substance has the nature to change into pink? Yes, absolutely correct. You understood from the table. It's about pink. So the base will convert the phenolphthalein into that. Okay, right? Next about this one, if you see, it's also not affected. So in these two, it is also colorless, it is also colorless. Now I want to find which is acid and which is neutral among these two. So that first I am going to take this one and I am going to add this, another one, methyl orange to this, methyl orange. See this, what is happening to this? It's converting into red. So methyl orange converts into red. Methyl orange converts into red. What is the substance? So acid, correct. So it is acid. Now when you add to this one, it's unaffected. So from this we can identify, we can conclude that test tube A is acid, it is base, and it is about neutral. With a litmus paper also we can identify the litmus paper. For example, if you see, it is blue litmus paper, blue litmus paper. Now I am going to take a leaf of blue litmus paper and I am going to insert with, what is this, diluted hydrochloric acid. So when it's to this one, you may see the changes in it. It converts into red, it changes into red. Now you may take one leaf of red litmus, it's about red litmus, and it's about sodium hydroxide, is a base. Let us see what happened to this one. You may see this, it changes into blue. So like this with the indicators. What are the indicators here? Litmus papers and of course phenolphthalein, methyl orange, all these are indicators. So in this first class only a simple concept we learn about the indicators and nature of the solutions. It is the first topic. I think all of you has analyzed. Let us see once brief introduction. Acids are sour to taste and converts blue litmus into red. Bases are bitter to taste and converts red litmus into blue. And several indicators are there. Indicators are nothing but the substances which are useful to identify the nature of the solutions. For that, one table is given for you, that is the content. Learn the content and apply the concept. The question may be asked in different nature. So you have to prepare different mode of questions with respect to academic standards. Good luck.